Okay, hello friends, I welcome you all on my YouTube channel Rasayan Setu. So friends, after a very long time I uploaded this video because one of you demands from me to upload this video, and in this video we can see the solutions of questions of chemical kinetics topics coming in CSIR net 2012 editions. Okay, and in this video we cover both edition, that is June and December. In June edition we have 5 questions, and in December edition we have only 1 question. Understand? Okay, let's start. Now see, this is your first question, and it was coming in June 2012. Okay friends, next 5 questions are coming in June 2012, remember. Okay, and this question is coming for 2 marks, and it says one of the assumptions made in the conventional activated complex theory is, and we have 4 options, that is equilibrium is maintained between reactants and the activated complex, and another 3 options are similar, in which reactants and the products and activated complex, and reactants, the activated complex and the products. So basically you must find that what is the assumption made in the conventional activated complex theory out of these 4 options. Okay, so this is your question. Okay, so let's do the solution. Now see friends, we all know that in activated complex theory, or we can say the transition state theory, we see that the reactant molecules approaches to each other and form a transition states. In activated complex theory or transition state theory, the reactant molecules approaches to each other and form a transition state. And what is the characteristics of transition state? That this transition state is a high energy state of the reactant molecules. It is a high energy state of the reactant molecules in which the bond breaking and bond formation takes place simultaneously. Okay, so for example we have 2 reactant molecules, that is A and B. So first of all, this A and B reactant molecules approaches to each other. A and B approaches to each other. Okay, and forms a transition state. This is a transition state of these reactant molecules. Okay, now after that the product formation occurs. That means the reactant cannot directly convert into product. First they form transition state, and this transition state can convert into product. Okay, so this is the reactant and this is transition state, and this step is known as the activation step. The activation step. Understand? This is the complete mechanism. Now when you closely see this mechanism, you clearly see that in this mechanism this transition state is in equilibrium with the reactant molecules. This transition state is in equilibrium with this reactant molecules. Okay, so that means you say that in the conventional activated complex theory or transitional state theory, the transition state remains in the equilibrium with reactant molecules. Okay, so transition state remains in equilibrium with reactant molecules. Understand? This type of equilibrium is known as quasi-equilibrium. The name of this equilibrium is quasi-equilibrium. Okay, So that means your option number A, that states that equilibrium is maintained between reactants and the activated complex, is the correct answer for this question. So option A is the correct answer. Understand? Okay, so now we move towards our next question. And see, it says, for a reaction, the rate constant at 27 degrees centigrade was found to be 5.4 into 10 to the power 11 e to the power minus 50. The activation energy of the reaction is, and we have 4 options, and this question is coming for 2 marks. Okay, so let's do the solution of this question. So in this question, you must find the activation energy of that reaction, and we have a values of rate constant and value of the temperature in degrees centigrade. Okay, so first of all, we all know that the Arrhenius equation is, so according to Arrhenius equation, what is the Arrhenius equation, friends? The Arrhenius equation is K is equals to A into A to the power minus EA over RT. This is called equation first. And in question, we have a value of K, that is 5.4 into 10 to the power 11 e to the power minus 50. This is called equation second. Now when we compare this equation first with equation second, so compare equation first with second, what we get? See, that 5.4 multiplied by 10 to the power 11 e to the power minus 50 is equals to A into e to the power minus EA over RT. Okay, it means here this EA, that is activation energy, upon RT is equals to 50. When you compare the first with second, we clearly see that this term is equals to this, that is EA over RT is equals to 50. Okay, and according to your question, you must find the value of this EA, that is activation energy. So that means your activation energy will be 50 multiplied by R multiplied by T. And in question, you have the value of T, that is 27 degrees centigrade, and you must convert it into Kelvin scale. Okay, so the value of R is 8.314 joule per Kelvin per mole. The value of temperature is 27 degrees centigrade is equals to 300 Kelvin. Okay, so the value of activation energy will be 50 multiplied by 8.314 multiplied by 300, and when you solve this calculation, this comes nearly equals to 1,25,000 joule per mole. 1,25,000 joule per mole. Okay, and it means the answer is option D. Option D is the correct answer for this question. Understand? Okay. Now we move towards our next question, and see, it says, during the addition polymerization, the reaction proceeds via, and we have 4 options, and this question is also coming for 2 marks. Okay friends, so let's do the solution of this question. It is again a very straightforward question. The addition polymerization reaction proceeds via step growth, free radical, cascade, or addition reaction. So friends, we know that the polymerization reaction, it have 2 types. Polymerization reactions have 2 types. The first type is addition polymerization, and the another type is condensation polymerization. In addition polymerization, it proceeds via free radical reaction mechanism. Addition polymerization proceeds via free radical reaction, where this condensation polymerization proceeds via step growth process. Okay, so in this question they ask about the addition polymerization. When they ask about the condensation polymerization, the answer should be option A, that is step growth process. But they ask about the addition polymerization, and addition polymerization is proceeds via free radical chain reaction. So option B is the correct answer for this question. Okay, option B is the correct answer. Understand? Okay, so we move towards our next question, and see, it says the rate law for one of the mechanism of the pyrolysis of acetaldehyde at 520 degrees centigrade and 0.2 bar pressure is, and we have rate law. The overall activation energy in terms of rate law is, and we have these four options A, B, C and D. So we have a rate law for pyrolysis of acetaldehyde, the value of temperature and pressure, and you must find the activation energy in terms of this rate law for this reaction, and these four options, and we have these four options. Okay, and this question is coming for 4 marks, remember. So that means it is coming in your part C, remember. Okay, so this question is coming for 4 marks. So let's do the solution of this question, friends. Now first of all, friends, we know that pyrolysis of acetaldehyde is a chain reaction which proceeds via free radical mechanism. So what is the mechanism of pyrolysis of acetaldehyde? See, in first step, this acetaldehyde is breaks in this CH3 free radical and CHO. This is a chain initiation step. Now in next step, this CH3 free radical is attacks on acetaldehyde molecule, and formation of methane and another CH3CO radical occurs. This CH3CO radical will again break into CH3 free radical and carbon monoxide. Okay, these two steps are known as chain propagation step. The first step is chain initiation. These two steps are chain propagation step. Okay, and in final step, that is chain termination, both CH3 and CH3 radicals can combine together and form a alkane. The rate constant for this step is K4. Okay, so this one is initiation, these two steps are propagation, and this step is chain termination. Okay, now when you solve this complete mechanism, when you solve the calculation for finding the rate law for this complete mechanism, applying SSA and the another required calculations, we must find the rate law. Okay, that is rate law for this pyrolysis of acetaldehyde is K2 into K1 upon K4 की power 1/2 CH3CHO की power. This rate law is coming out for this complete reaction. Okay, so the rate law is K2 K1 upon K2 to the power 1 by 2 Now first of all, taking log for this complete equation. So log K is equals to log K2 plus log K1 upon K4 की power. How can we solve these log terms? See, we have a formula for you know the formula for solving logarithms, that is log A into B. Log A into B is equals to log A plus log B. Okay, so here log A into B is log K2 into log K1 upon K4 to power 1 by 2, that is log A plus log B, that is log K2 plus log K1 upon K4 to the power 1 by 2. Okay, now the next formula we use, that is log x to the power m is equals to m log x. We use this formula for this term, that is log K1 upon K4 की power 1 by 2. So for applying this formula on this equation, we get log K is equals to log K2 plus 1 by 2 log K1 upon K4. Understand, friends? Okay, it is a very simple calculation. Now the next log formula we use for calculating this equation is log A by B. So log A by B is equals to log A minus log B. And we use this log A by B formula for this term, that is log K1 by K4. Okay, so from this equation we get the equation is log K is equals to log K2 plus 1 by 2 log K1 minus log K4. So this is the complete calculation for the rate law of the pyrolysis of acetaldehyde in terms of logarithm. Okay, now this now how can we write this equation in terms of energy? So in the terms of energy, it can be rewrite as EA is equals to energy of activation related to second step, that is log K2 plus 1 by 2 energy of activation related to K1, that is step 1, minus energy of activation related to step 4, that is 4. Okay, so we can rewrite this equation in terms of energy, and according to this equation you can clearly see that this is related to your option B. See in the corner, the option B is the correct answer for this reaction, that is known as pyrolysis of acetaldehyde. Understand, friends? Okay, so this is the complete solution of this question. We use general log formulas for the solution of this equation. Understand? Okay, so now we move towards our next question, and see, it says in the Michaelis-Menten mechanism for enzyme kinetics, the expression obtained is, we have this expression, the values of K3 and K, that is Michaelis constant, respectively are. So in this question we have an expression which is obtained for Michaelis-Menten mechanism for enzyme kinetics, and by this expression you must find the values of K3 and Michaelis constant. Okay, and we have 4 options, and this question is also coming for 4 marks. Understand? Okay, so let's do the solution of this question, friends. Now first of all, what is the enzyme catalysis mechanism? In general, we write that enzyme and substrate can react with each other and firstly form a transition state, and after that formation of product occurs. This is a enzyme catalysis, or you can say enzyme kinetics mechanism. Okay, this is a reversible step. The rate expression for this forward reaction is K2, the backward reaction is K2, sorry, this is K1, forward reaction, K2 for backward, and the rate constant for this step is K3. Okay, and for this reaction the rate law is what is the rate law for Michaelis-Menten mechanism? The rate law is V is equals to V max multiplied by S upon S plus. This is a general formula we all know. That is the rate law in Michaelis-Menten mechanism. Here we all know that the value of V max is equals to K3 multiplied by E naught. So put the value of this V max in this equation. We get the value of V is equals to K3 into E naught multiplied by S upon S plus Km. Now in next few steps we open this equation or we calculate this equation. Okay, how can we open this? C? Now that means V upon is equals to K3 upon S plus K. So by this equation the value of K3 is equals to V upon E naught S multiplied by S plus K. Okay, so the value of K3 is equals to V into S upon plus we can just rearrange this equation. Okay, it is not a complicated step. We can just rearrange this equation. Okay, so now when you rearrange this equation, this S is cancelled out by this S, so K3 is equals to V upon E naught plus V into Km upon just rearrange this equation. Okay, so that means K3 minus V upon E naught is equals to V into Km upon that means V upon naught into S is equals to K3 upon Km minus V upon E naught into This is the final expression we get by rearrange this equation. When you rearrange this equation, this is the final expression we get. That is V upon E naught into S is equals to K3 upon Km minus V upon E naught into Km. Understand, friends? Okay, this is the final expression we get. Now in question, first of all, assign first for this equation. So this is the equation first, and in this question we have a value of this V upon E naught into S equals to 1.4 multiplied by 10 to the power 12 minus 10 to the power 4 V upon E naught. This is equation second. So equation first we obtained by the expansion of that equation, and equation second is given in your question. Now when you compare the first one and second one, when you compare this first and second equation, you clearly see that by this comparison, the value of K3 upon Km is equals to 1.4 multiplied by 10 to the power 4, and the value of 1 by Km is equals to 10 to the power 4. This 10 to the power, this K3 by Km is equals to 1.4 into 10 to the power 12, and this 1 by Km is equals to 10 to the power 4. Okay. So first of all, what is the value of Km? In the question you must find the value of Michaelis constant, that is Km. So by this expression 1 by Km is equals to 10 to the power 4, the value of Michaelis constant is 10 to the power minus 4. We get the value of Michaelis constant, that is 10 to the power 4 mole per liter, and put the value of this Km in this equation, that is K3 by Km equals to 1 by 4 into 10 to the power 12. When you put this Michaelis constant value in this equation, that is K3 by Km, you get the value of K3. So the value of, by putting the value of Michaelis constant in this equation, the value of K3 we obtained is 1.4 multiplied by 10 to the power 8. Okay. So the value of Michaelis constant is 10 to the power minus 4 mole per liter, and the value of K3 is 1.4 multiplied by 10 to the power 8 mole per liter per second. And by this result you clearly see that the option C is the correct answer for this question. Option C is the correct answer for this question. Understand, friends? Okay, see once again the complete solution of this question. There is nothing but just the rearrangement of this equation, or you can say that rearrangement of the rate law for the Michaelis Menten mechanism. When you rearrange this equation you get your answer. Understand? And this question is coming for 4 marks, remember. So these 5 questions are coming in CSIR net June 2012 edition. The next question is question number 6, which is coming in December 2012 edition. Okay, this is the only question which is coming in December 2012 edition from chemical kinetics topic. Okay, so let's see the question, friends, and see it says the Arrhenius parameters for the thermal decomposition of NOCl and this reaction gives are the value of A activation energy and RT given. The enthalpy of the activated complex will be, and we have 4 options. So in this question you have the values of A activation energy, RT, and you must find the value of enthalpy of the activated complex for this reaction. And this question is coming for 4 marks, which means it is coming from part C, and remember it is a December 2012 question. It is coming in December 2012 12 question, December 2012 edition from chemical kinetics topic. Understand? Okay, so let's do the solution of this question. The reaction is 2 moles of aerosol gases converts in 2 moles of NO plus 1 mole of Cl2. Okay, this is the question. You must find the value of enthalpy of the activated complex. So friends, we all know that a thermodynamic relation between the activation energy and the enthalpy of complex. The relation states that the activation energy is equals to delta H plus RT 1 minus delta Ng. By rearrange this equation, we get that the value of delta H is equals to EA minus RT 1 minus delta Ng. So that means delta H equals to EA minus RT 1 plus this minus will become plus. Okay. Here delta H is the enthalpy of the activated complex, EA is equals to activation energy, RT, and delta Ng. Remember, the delta Ng is the difference between number of moles of product minus number of moles of reactant. Okay, and in this equation, what is the value of delta Ng? Here, see. Number of moles of product are 2 plus 1, that is 3, minus number of moles of reactant are 2. So the difference between numbers of moles of products and reactants are 1. So the value of delta Ng is equals to 1. So the value of delta H is equals to enthalpy of activation is, according to question, is 105 minus the value of RT is equals to 2.5 to 1 plus the value of delta Ng 1. So it is 105 minus 5 is equals to 100 kilojoule per mole. So the enthalpy of activation for this reaction is 100 kilojoule per mole. That is your option D. Option D is the correct answer for this question. Understand friends? See once again the complete solution of this question. Okay. So friends, ये थे आपके क्वेश्चंस जो 2012 एडिशन में केमिकल काइनेटिक्स टॉपिक से पूछे गए थे. आप में से ही किसी ने कल ये डिमांड करी थी मुझसे कि प्लीज़ 2012 के क्वेश्चंस अपलोड कीजिए, तो ये रहे उसके सॉल्यूशंस. आगे भी फ्रेंड्स मैं अपनी पूरी कोशिश करूँगा. आपके जो भी डिमांड्स होगी कमेंट सेक्शन में बताइए. कंसिस्टेंसी नहीं रही है पिछले कुछ टाइम से, ऑलमोस्ट 1 साल हो गया है जो मैंने लास्ट वीडियो अपलोड किया था और अब भी वीडियो अपलोड कर रहा हूँ. बट अब कोशिश करेंगे साथ चलने की. आपके एग्ज़ाम्स भी आ रहे, जून एडिशन वाला नेट एग्ज़ाम भी होने वाला है. अगर उसके रिगार्डिंग कुछ आपको क्वेरीज है, कुछ सॉल्यूशंस चाहिए, कुछ ऐसे क्वेश्चंस जो आपसे नहीं सॉल्व हो पा रहे हैं, आपको उसके सॉल्यूशंस चाहिए, तो प्लीज़ कमेंट सेक्शन में आके ज़रूर बताइए. आई विल ट्राई माई बेस्ट. ओके, अच्छे से तैयारी करते रहिए. थैंक यू सो मच. थैंक यू फॉर वॉचिंग.